Thank you, John. And if that was the worst thing people said about my book, I'd be very happy indeed that you need to read it with a drink in your hand. So in my presentation this morning, I want to echo my book, and I want to make three key points. First of all, that there are a number of cognitive and operational biases that have been observed by myself and others over the years in foreign aid that are increasingly at odds with the world that we live in, the world that we work in, but which continue to exert an undue influence over what we do in aid, how we do it, why we do it, and how we report on it. The second point I want to make is that many of the problems that we face today in development and humanitarian work can be rather better described, understood, and navigated using the ideas from the broad area of complex adaptive systems research. And the final point I want to make is that the approaches have considerable and increasingly proven relevance for the work that we do in aid in terms of providing better descriptions and explanations for a whole host of real-world phenomena, and indeed informing programs which can be more adaptive and more responsive to those situations. And thereby we can actually address the first problem I talked about. We can use these approaches to bust enduring but flawed assumptions and help to develop aid work that is more relevant, more appropriate, more catalytic, that makes more difference to the people that we purport to be helping. So let me begin with an account of what I describe in the book as an enduring myth in the annals of aid history. It's the eradication of smallpox. And it's one of only two diseases to be eradicated in human history, the other being rinderpest, which is a cattle disease. And what's interesting is the way that smallpox is eradicated, although smallpox is often talked about as being one of the major achievements of the World Health Organization and indeed the aid sector as a whole, the way in which it was eradicated is not widely talked about or understood in the aid sector. The main WHO website makes reference to a global mass vaccination campaign led by that entity. And it's typically described in very top-down ways. It involves the rollout of simple, standardized processes, moving from one country to the next in nice, well-oiled mechanical fashion, and reaching optimal vaccination rates. There was a magic number of 80%, which historically helped to eradicate smallpox in developed countries. What's interesting is when you go into the historical accounts and the accounts of the people that were involved, you find that mass vaccination was not the only, or even the most important aspect of the strategy. The most detailed accounts we have point to a rather different story, which is only really partially acknowledged in the official histories. And what these suggest is, contrary to popular belief, there were innovative and experimental approaches to the strategy around surveillance and containment that were far more important and helped to break the transmission chain of smallpox, even in those countries where less than 50% of people were vaccinated. And the successful strategy, which is typically presented as a success of top-down planning, a highly visible approach of applying vaccination, was in fact a process of emergent, adaptive, networked experimentation. Each country had to develop unique, context-specific approaches, and even those involved in the campaign did not plan for or envision what the relevant approach would be at the outset. The campaign had to adapt and learn and adjust to context, as Dale Henderson, the much lauded director of the campaign, talked about. It was a continual process of evolution. And this learning process, more than any other single factor, has been described by those involved as the single most important contribution to the success of the campaign. Now, the director of the WHO, in his speech announcing the eradication, announced that it was a triumph of management, not of medicine. Apart from it being a very interesting thing for the WHO leader to say about that organisation's preeminent achievement, I think the comment also highlights a rather stark fact, that the official history and the widely accepted narrative says almost nothing about the exact nature of this managerial success. Now, you might be asking why I'm telling this story. What I would argue is that this illustrates something that's very widespread in aid, that aid institutions strongly incentivize the use of certain kinds of language, certain kinds of mindsets, certain assumptions and approaches to explain and describe what we do in aid, what we want to do, how we do it, and what we did. And this applies even to tremendous successes, and often in the face of the available evidence. Now, the reason for this, I argue in the book, is that development and humanitarian aid institutions are shaped by and anchored in certain mental and cognitive models. And you can see evidence of this throughout the strategic, learning, performance, and organisational frameworks, all of which I examine in some detail in the first part of the book. And if I was to summarise this, we seem to think and act as if the economy, the natural resource systems we're exploiting, societies and the world as a whole are equivalent or analogous to a series of wind-up clocks or car engines. We act as if we can predict and often exactly manage the behaviour of the systems around us by breaking them up into manageable pieces and working on those pieces individually. And the role of aid leaders, aid managers, of policymakers, is to engineer and construct change through reductionist analysis, prediction, planning, standardization and control. And these assumptions underpin large amounts of what the foreign aid system tries to do, whether it's community development efforts or long-term statewide reconstruction efforts, or governance processes, or indeed large-scale global health programs. Now, these are implicit assumptions that, in the extreme, add up to a series of institutional and cognitive biases, operational biases. And let me just take you through these quickly. There's an assumption that the social systems, economic systems, natural resource systems are closed, that we deal with, are closed, ordered, and reducible to the parts that we're most interested in, while everything else is held constant. That these systems are nothing more than the sum of their parts. There are assumptions about relationships, that we can deal with individuals, institutions, entities, in effect as if they're independent and atomized, that their most important characteristics are to be found at the individual level, and that contexts and relationships between them are irrelevant, ahistorical, or can be reshaped and rewritten by external actors. About behaviours, that humans make rational decisions based on self-interest, and that these behaviours can be specified in top-down ways and changed by simply changing the elements of this kind of elaborate calculus. And about change, that change is linear, additive, there's simple cause and effect, that there's a proportional relationship between inputs, outputs, and outcomes, and that more inputs should naturally lead to more outcomes. It's a world of nice straight-line graphs and straightforward XY relationships. Now, these ideas have their origins in 19th century physical sciences, and they found their way into organizations and institutions through neoclassical economics, through scientific management principles, and through the idea of bureaucracies of the early 20th century and the late 19th century. So these are the assumptions, these are the ideas that Henry Ford used to deliver any colour car as long as it was black. And so, perhaps unsurprisingly, they're most useful, they come into their own, they work brilliantly in situations where machines work well. They work well where there is a straightforward task to perform, a stable context and operating environment, identical duplicable products, compliant, reliable, predictable parts, which includes the human components. Now, hands up anyone who feels that their working environment resembles this picture. But this is precisely how the smallpox campaign is often imagined to have worked. And this is the story that was told afterward for many years, and is still being told in many quarters. And it's the same kinds of assumptions that underpin the famously failed malaria campaign of the 1960s. This is a description of that campaign written around the time, which mandated identical job descriptions in every country with prescribed charts to be displayed on every office at each administrative level, and the programme being conceived and executed as a military operation which is to be conducted in an identical matter, whatever the battlefield. And interestingly, research was considered unnecessary and was effectively suspended from the launch of the programme. Now, the smallpox campaign deliberately set out not to emulate the malaria campaign for exactly this reason. But the same kinds of assumptions underpinned integrated rural development efforts of the same period, and they continue to shape what could be described as big aid. So if you look at global education initiatives, as recently described by Lamp Pritchett, the low-cost package of inputs that the Millennium Campaign assumed would be the key to achieving the MDGs, or the harsh reality of the Millennium Village projects, as recently described by Nina Monk. Now, it may seem risible to say this, but this is the illusion, this perfectly Newtonian world, that aid institutions, the aid counter-bureaucracy, as Andrew Natsios memorably called it, demands be maintained in the face of the evidence. And the frustrations with this model are running at fever pitch across the bureaucracy that John described earlier, whether we're talking about donors or NGOs or UN agencies or national governments. A donor agency representative of fairly senior level said, we don't actually want research or science. What we really want are simple problems with simple answers so we can demonstrate value for money. I think he said that as much out of frustration as anything else, but I think it's really indicative of the way in which this model is being applied ever harder in the face of its failures. And I think what's interesting is everyone from senior leaders to external critics are talking about the outmoded business model of aid. And I'd argue that this series of assumptions, in part at least, is what they're talking about. Now, I'm not saying that there's any individual that believes these things, or there's any institution that formally says these are part of the way that we see things. It's more that this is hardwired into how aid works. I think there are people that work in remarkably creative and innovative ways in the aid sector, but they often do this in spite of the institutions that they work in rather than because of them. And I think what the smallpox case does is it really powerfully illustrates how pervasive this is, when one of the most remarkable successes, which was a success of adaptive experimentation, is subsequently overwritten by tales of mechanistic standard operating procedures. So I think the reason this is so important is that if we continue with this addiction to reductionism, we risk learning the wrong lessons from our successes and not learning at all from our failures. Rather less portentously, I think the aid sector exemplifies Duncan Watts' memorable quip, likening the Newtonian model to a Shakespearean character. It's staggering around the global stage like a mortally wounded actor. And I think it's worth asking, given that every generation of aid critiques comes up with some version of this problem, from the 1960s, Albert Hirschman, Robert Chambers in the 1980s, Bill Easterly in the noughties. Why does this model so steadfastly refuse to die? I think in part it's because there are development problems, a small number arguably, that need to be addressed with exactly this kind of model, where exactly this kind of Newtonian reductionist approach is what needed. But to paraphrase Keynes, I think a more fundamental reason is that in the aid sector at least, it's better for individual and institutional reputation to fail conventionally within the confines of this model than it is to succeed unconventionally by moving beyond it. So let me move on to the second part of my talk. The obvious reality is that development and humanitarian problems and the world at large are not like Newtonian clockworks. They're not like Ford motor cars. And growing numbers of experts have been pointing to the ideas of complex adaptive systems as an alternative theoretical model for development. And this is what I explore in the second part of my book. And there's a history to these ideas which actually helps us grasp why and how they're important. The seeds of what many describe as the new complexity movement were actually sown 60 years ago by Warren Weaver, who was the science vice president of the Rockefeller Foundation. And I think he was a forgotten giant of the 20th century scientific research. He did work on everything from microbiology to anti-aircraft missiles. He personally mentored over 20 Nobel scientists. So he was a very humble man. I think it's part of the reason why he was forgotten. I tell his story to some extent in the book, but essentially, 1948, after the war, Warren Weaver found himself in a position not dissimilar to many donors today. He tried to think about the kinds of problems that his foundation, one of the leading ones in the world, should be trying to address. And as I just hinted at, he was a real polymath, so he was well placed to do so. And what he observed was a significant gap in the activities of the foundation, and indeed in science and in policy community as a whole. What he found, what he argued, was that there were three kinds of problems in science, and that there'd been more progress on dealing with two of them than on the third kind. And the first kind are exactly what I've been talking about. They're kind of the problems that aid agencies are addicted to. And these problems are of a few variables, so the trajectories of a rocket, Newtonian mechanics. These kinds of approaches, this kind of scientific thinking, underpins many of the advances of the industrial era. So from transportation to germ theory to many forms of basic health provision. So, there's nothing wrong with these problems. When I often find myself talking about the things that we got from the sciences of organised simplicity, it reminds me of the what did the Romans ever do for us scene in Life of Brian. But actually, what was interesting is at the end of the 19th century, around the end of the 19th century, start of the 20th, Scientists, as Warren Weaver saw it, leapt to the other extreme and started thinking about problems of disorganized complexity. And these are problems with many variables, all of which interact in random fashion. So the motion of atoms, or thermodynamics, statistical mechanics, the kinds of maths or statistics that's used in population studies, or actuarial analyses, the kinds of things that insurance companies still use in order to analyse risk across a population and turn a profit. Now, what's interesting, and what he identified in between the two, were problems of organised complexity. And these were not problems that could be broken down into one or two equations. They weren't problems that you could easily apply averages to. There were systems with a sizable number of factors that were interrelated into an organic and intricate whole. And so you can't, and the kinds of things that he talked about were commodity prices, or economic development, or the growth of cities, or mass social movement. And what he argued was that scientists and policymakers and funders had put much more effort into the first two problems and relatively little into the latter. And Weaver also argued that almost all of the major challenges that humanity would face in the rest of the 20th century would be of the third variety. And he called for what he described as a third great advance, which would combine multidisciplinary cross-scientific working with the power of what he rather touchingly called advanced counting machines to better understand and navigate these problems. Now, in part 2 of the book, I describe the progress on this advance, specifically as it applies to economic, social, and political contexts. What's really interesting is that Weaver has had quite a considerable influence across the intellectual spectrum. There's at least 2 Nobels in economics, Friedrich Hayek and Herb Simon, who were highly influenced by his ideas and cited him in their Nobel acceptance speeches. Jane Jacobs, who is perhaps the most influential scholar of the 20th century on urban issues, drew extensively from his ideas. And his work directly contributed to the field of systems thinking, to machine learning, to the work of the Santa Fe Institute. And at 6 pages long, it may well be the most concise piece of work ever to have inspired a new movement in scientific thinking. And many would argue that we actually now live in a world dominated by complex, adaptive systems with exactly the characteristics that Weaver described. That they are systems of many interacting agents and organizations of agents. They're adaptive in that the agents design strategies and they evolve over time. And they're systems in the sense that the macro patterns emerge from micro behavior. So if we look around us, we can see ecological systems are complex, and the costs of treating them as simple machines are self-evident. Climate is clearly complex and non-linear. The economy is complex at national and at global level. The energy is increasingly complex. North America used to be the kind of standard version that people talked about when they talked about energy complexity, but actually you could easily refer to the UK or European systems and point to the complexities within those systems. Food systems, information systems, communities, organizations, they can all be usefully analysed and understood as complex systems. Now, complex systems is a vast and multifarious area, and there seem to be new areas emerging all the time. And in the research which I did, which I have to say actually, the initial work I did with Harry Jones, who's in the audience, whilst at ODI, and then I built on that work by doing more research at places like the Santa Fe Institute and at the LSE. And this kind of emerges really from the work that I did with Harry, and also I kind of spell it out in the book as well, that we can identify some distinguishing features of social, political, and economic complex systems. And by identifying that, we can get a handle on the problems within them. And what I've identified, I'm not saying these are the only approaches that are useful in social complexity, but these are the 4 main areas where there's been a lot of work done to date. And it's systems, networks, behaviors, and dynamics. And let me talk through these briefly. So complex systems approaches help us think about systems that are not reducible to 1 or 2 variables of interest. That essentially enables us to take a wide-angle lens on the problem that we're dealing with and understand how they're shaped by feedback and interdependence. It helps us think about networks between people, groups, communities, products, as I'll talk about shortly, to understand the underlying structures of social, economic, and political relationships and how these change over time. It helps us be much more realistic about behaviours, about how we actually think and make decisions individually and collectively, and how incentives and interactions shape our adaptive actions. And it sheds light on the real-world dynamics and patterns that we observe in the world around us, which aren't straightforward and linear, where you can't hold one thing constant, but which are non-linear, which are characterized by tipping points and phase transitions and surprises. Now, these are all broad families of approaches, so within each one of these there's a huge literature. But what they do is they help us better understand, and I would argue navigate, complex systems. And some of the bona fide complexity scientists in the room will be keen to point out there are many more families of approaches out there. But these are the ones which I think have seen most application to the social settings, which are central to development. And what I try and argue in the book, and what I show in the book, is that together these ideas, these approaches, provide an alternative to the modus operandi, the standard operating assumptions of aid that I described earlier. So let me just briefly close then by talking about how these ideas can be applied as a way of thinking about development differently. So in the book there's over 25 case studies across these different areas of aid agencies and aid individuals that tried new ways of thinking and working and who were able to achieve dramatically new, improved results. And they're to be found in every sector, from education to health to conflict to natural resource management. And because of the limited time I've got, I've just chosen one short case study from the area of network science to illustrate how complex systems approaches can be utilised in development humanitarian aid. Now, network science, I mean, it is talked about a lot. The key thing is we're all affected by networks, by webs of relationships, whether they're social, economic, or biological. And these networks are often invisible, but they can have profound influence on everything for us as individuals, on our mental and physical health, on our socioeconomic status, even on our life expectancy. Consider, for illustration purposes, a small network of executives in a large petroleum organisation that was considering going through a restructuring. And what they essentially decided quite early on was they wanted to get rid of everyone below this layer here, Williams, Taylor and Stock. What they actually found, they conducted analysis and they tried to understand who was most central to work being done across this senior management team. And although this was the formal organisational chart, and in which this individual, Cole, would have been essentially let go of, this person was absolutely central to the conversations and dialogue that helped work happen. This is the network analysis which actually revealed this invisible pattern. And so Ms. Cole was of central importance to the entire division, but you wouldn't know this from the formal organisational chart. And for this reason, social network analysis is often described as an organisational X-ray. It reveals patterns of connectivity within specific functions and divisions or business units or across entire organisations. But it can also be used to reveal patterns of productivity, of energy use or flow, of political affiliation, of interfirm relations, of gender equity, of disease spread. In the last 2 years, I've led teams doing work on water sustainability in Ghana, on political affiliations in Uganda, and on gender equity in Nigeria. So I think the potential applications are literally endless. The case study I want to talk about, and it's one that's had quite a lot of attention, is work done by Harvard and MIT, which was led by Ricardo Hausmann, which is a former CEO of the Inter-American Development Bank, and Cesar Hidalgo, who's a network scientist and physicist. And what they developed was a network-based approach that formalized the idea of networks as being a really fundamental way of understanding economic performance. And essentially what they tried to spell out, what they tried to do was essentially start with the idea that much development thinking around economics doesn't engage very well with this idea of webs and networks. Such ideas run counter to standard thinking, a lot of which tries to identify differences between individuals and groups or countries based on their aggregate qualities or their inherent qualities, so things like socioeconomic data for individuals or demographic criteria or GDP. So experts then puzzle over why countries with very similar GDP might end up in very different development pathways over time, or individuals that seem to have very similar socioeconomic status initially end up in very different places. What they actually identified is, in many cases, the relationships and networks between these entities and within these groups proved to be a key differentiating factor. And if the data is available and it can be analysed, it's possible to develop very precise and rigorous analyses of these differences and thereby explain them. So what Ricardo, César and others found was that the structure of national productivity networks, what they call the product space, which I present here in generic form, provides a very powerful explanation for why some countries undergo economic growth while others stagnate. Essentially, this is a map of the relatedness of the products produced by a given country, and the different colours denote different kinds of products. So purple, for example, is medicines, and light blue is computer-related technologies, and so on. What they found was, having analysed a whole series of countries, and I'm simplifying their story for reasons of conciseness, this network essentially conditions and shapes the development of nations. And by through network analysis, they were able to get a sense of the opportunities of development. Essentially, what they argued, or what they found, was that similar goods depend on similar institutions, similar inputs, similar factors of production, similar technologies. It was inspired by Ricardo's observations of Peru and the production of export of artichokes in Peru, and how this created almost all of the conditions necessary for the export of asparagus. And it sounds like a very simple example, but actually the soil conditions, the climate conditions, the packing technologies, the logistics, the trade agreements, all of that added up, which meant that when Peru decided they wanted to diversify into asparagus and artichokes, they're able to do that very quickly by redeploying a lot of those original capabilities. But if they tried to move into an entirely new area like toasters, then the capacities they'd already developed would have been little or no use. And that same principle, that very simple principle, could be applied to entire economies, that networks of productive knowledge underpin growth, and that it can be applied across entire economies to generate both data and powerful visualizations. Now, what's really interesting is that this provides a new and important explanation of a classic development question that anyone that studied economics would have probably come across, or indeed people studying development studies at the undergrad level. Why Ghana and Malaysia, which started off in 1957 at the end of colonialism, as both largely rural, poor countries with very similar GDPs, why they've gone on such different trajectories. Now, Ghana is the first chart here, and Malaysia is the second. And the black squares indicate the area of the product space that, I don't know how I go back here. Yeah, so they indicate the areas of the product space where their countries have a relative comparative advantage. And the bigger the square, the bigger the contribution to world trade of that commodity from that country. And I was trying to develop a kind of visualization which was animated, but was a bit concerned about the technological kind of failures that might happen. But essentially, Malaysia built on its agricultural base. The picture of Malaysia in around 1957, 1960 is not dissimilar to this at all. But what happened was that Ghana largely remained, as it did in the 1960s, reliant on raw material exports. And they tried to diversify in ways that were suggested or recommended by external development organizations, moving up the supply chain very quickly, but those efforts were not sustainable. Malaysia, on the other hand, took much more of a kind of Chinese approach. You know, you have to cross the river one step at a time, and you have to go one stepping stone at a time across the river. And what they did was that they diversified by building on the things that they were already good at. And actually what's interesting is that they both start off with palm oil as one of their key natural resource exports. And Malaysia diversified from palm oil and started producing all kinds of ancillary things. So now, for example, chemicals and electronics are all being produced by Malaysia, all of which started off from their kind of agrarian base, whereas Ghana didn't do anything like that. So I think what's really interesting about this approach, and Ghana today is still largely reliant on raw material exports. I think what's really interesting is it brings analytical rigor to the complex and dynamic nature of economic growth. And it gives us the ability to answer long-standing and challenging questions much more precisely. And one of the developers, César, summed it up for me. He said that the traditional approach to economics has retained measures that were developed in the 1930s and 1940s to deal with the situations and the crises that we faced back then. And what they're trying to do is develop a new series of measures which have much more precision and much more resolution and that mean that we don't continue to build our analysis and our policy making and our practices on the oversimplification of complex systems. And I think it also points to a different approach when trying to promote growth, that you need to look to the existing product space, you need to see how it's evolved, and you need to see how the network can continue to be evolved and grown rather than designed, that aid agencies need to be less architects of change and more like gardeners. And before you kind of think that's, homespun wisdom, this is actually an incredibly powerful technique. The Economist described it as being better at predicting economic growth than any other available tool, including the World Bank techniques and the World Economic Forum techniques, by a factor of 10. So I think that's quite an astonishing revelation of how powerful this kind of approach can be when you've got the combination of the analytical tools and the data. Now, the key to this case study and all the others in the book is how the proponents, Ricardo and Cesar and all the others that in the story I tell in the book, how they use these new ideas and data-driven approaches to challenge and transform our understanding of problems, use that understanding to displace long-held and inappropriate assumptions, and in effect help understand the full diversity of problems that we face, that there are some things that are indeed simple problems and we should be dealing with them as such, but also that there are a whole series of lenses we could be using on problems that are of organised complexity. And if we don't use those, we wouldn't fully grasp them. And if we don't grasp them, we can't properly address them. So the kinds of things that complexity research brings, I've already talked about, but I think it's useful to compare the two, so the kind of sciences of simplicity and what the science of complexity bring to our understanding. And I think, I guess this is my one of my closing points, that really we can see this as a challenge or an opportunity. There are many people that I've come across and in many development agencies that actually say what we need to do in the face of complex problems is apply the sciences of simplicity even harder. That at the bottom of these problems, you must be able to find an XY relationship in an equation. And actually, when I pointed out to them that was a bit like a biologist that didn't believe in evolution, but just wanted to understand the functions of eyes or ears or limbs all separately, their response was, well, actually, maybe there are some biologists that don't need to believe in evolution, which I think is quite an interesting illustration of how entrenched some of these ideas can be in development. But I think the key thing to say is that complexity thinking isn't the only way of busting these assumptions. It's not the only way of moving to the bottom row. And there are many heterodox social scientists, anthropologists, sociologists who will be keen to point that out. But I think it's one of the few ways that enable us to challenge all of these ideas at the same time. So not just kind of what happens at the moment is that there's a little bit of behavioural science tacked onto an otherwise standard model, or a little bit of network thinking bolted onto an otherwise kind of typical way of thinking about the way the world works. What complexity thinking enables us to do is challenge all of these existing biases and issues at the same time. And so I think it has real potential to improve the way in which we think about and do work in aid, so that our work has much more fidelity to the world that we live in. And the key isn't the wholesale and unthinking application of complexity approaches, because as I said earlier, there are many situations in which the traditional approaches work perfectly well, but we have to be able to work out the detail ourselves. We have to be able to find the hypotheses that are relevant for the problem that we face, and we shouldn't be turning complex systems research into a panacea on the one hand, or an excuse for our own pet project that we've been banging on about for years on the other hand. And I've seen lots of examples of both those in the last few years. I think it's not about saying everything is complex. It's about saying we need to be more scientific in development, and we need to be drawing on the whole range of scientific tools that are available to us. We need to deal with complex problems accordingly, and when there are simple problems and simple models work well, we need to apply those as well as we can. So, a couple of quick closing thoughts. I think, just echoing John, that the world that we face today is not the one that we expected to be living in 20 or even 10 years ago, characterised by uncertainty, unpredictability. John's comments actually made me think of the joke by Terry Pratchett that 1,000,000 to 1 chances prop up 9 times out of 10. But I think we have this kind of cascading global crises. We have new and unanticipated vulnerability and opportunities around us. And what's becoming ever more important from a public policy perspective is that we need new ways of thinking and new ways of acting if we're going to be able to better solve the problems that we've created, if we're going to navigate the turbulent years ahead of us. And we cannot solve some of the major problems we now face using the mindsets we've inherited. So I think that this new normal world that many talk about makes the goal of understanding and navigating complexity rather than simply dismissing or ignoring it ever more essential and urgent. And if we want development to be more relevant, more realistic, more scientific, this is a really important path for us to follow. Let me close briefly by returning to the smallpox case and my favourite story from the campaign, apart from how it actually worked. Now, many of the heads of the WHO were actually deeply sceptical that the eradication effort would work. And in India, the most senior official went as far to say that if the campaign was successful, he would eat the tyre from his 4x4. Soon after the campaign ended, Don Henderson, who's the leader of the campaign who I cited earlier, actually sent the gentleman a Jeep tyre. History doesn't actually reveal what happened to the tyre, but I like to think that the man was a man of his word. And I'd like to think that he dutifully chewed each mouthful of this delectable piece of machinery, and perhaps with some appropriate condiments, and that he would have reflected on the need perhaps to rethink some of his ideas, and maybe even change his way of thinking. I wonder if there might be an analogy there for AIDS mechanical addiction. It's an image I quite like, and it's one I'm going to close with. Thank you for listening.